this point. Okay, so percent error. I'm going to add something up here. Okay. With percent error, it's pretty much identical to what we've been doing. We're finding the change. Then we're finding the percent. Okay, they just use different words. So the thing that we've been doing is change over original, but with percent error, it's the change in the error change over the exact amount. Okay, so absolute error means that the difference, and remember difference is subtracting, so make sure you put that on there. Okay, the subtracting the difference between the approximate value and the exact value. Okay, so an example of that, and don't yell out, this is just what I'm going to say. So Andy, I think that his IQ is 110.
That's all.
Okay, hold on. But his actual IQ is 105. Okay, hold on. I predicted that his IQ was 110, but his actual IQ is 105. What was the difference in the amount?
5.
5. And the difference is we just subtracted.
I do that.
So we take that difference and we put it over his exact IQ and then cross multiply like we did before. Okay, it's literally no different. So it says it can be solved by finding the absolute value, which I prefer just to say the big minus the small. And that's the change. Okay, does anybody know what an absolute value is?
Yes, I do.
Absolute. What's absolute value do to a number?
Subtract.
No.
Jimmy?
If it's a negative, it makes it the opposite of even.
No, it's not me.
Yeah. It's the opposite.
You're on the right. He's on the right track. Let him know.
It's that positive number instead of a negative number.
All right. So absolute value always makes a number positive. Is what it does. Absolute value. So if I say what's the absolute value of 5, it's 5. What's the absolute value of negative 3? It's positive 3. What's the absolute value of 2? 2. What's the absolute value of negative 10? 10, because it always makes it positive. But I just for time's sake, I just do big minus small, and that always keeps it positive. Okay. All right. So it says use your understanding of absolute error to answer the questions below. So on number 1, it says a science experiment calls for 150 milliliters of water, but Simon measures out 147 milliliters. What is the absolute error? So what is his error in measuring? And everybody would say 3. So I can subtract 150 minus 147, and his error is 3 milliliters. He had a measuring error of 3. Now, this one did not ask for what is the percent of error. It just asked what is the error. So it's just getting you in the practice of finding the error, right?
What if I ask you the percent of it?
We'll get to that in a minute. All right, number 2.
3 grams.
I didn't ask yet. A student measured the mass of an object to be 56 grams, but the actual mass was 53 grams. What is the absolute error? So I just subtract them. I would subtract the big minus small, so 56 minus 53 is again 3 grams of error. So when I go right here to find the error change, I just subtract. And then I put it over the exact amount. Okay? All right, so getting down into here, percent error compares the absolute error to the exact amount. we're gonna scribble this part out, no, I get. All right, and we're also gonna put on our notes here. To find percent error, you can still use your percent proportion. And they call it the approximate minus the exact, but I call it the error change. So what was the change in error? So the change in error for the milliliters was 3, because I just subtracted them. I always subtract to find the change. And then I put it over the exact, and then I cross multiply. So make sure you scribble that out. You wrote error change in that spot. Okay. All right, so looking at this next directions, it says during a school assembly, Mrs. Quinn takes attendance and counts 356 students. In actuality, there were 376 students. What is the percent error? So since it's asking me for the percent, that means I'm going to use the percent proportion. Okay, so we know that she counted 356, but there was an actual 376 students. Okay? Actuality means that's the actual amount, the exact amount. So first thing I'm going to do is subtract them to find the change, to find that error change. So 376 minus 356, and we find that that's 20 students. That's the change. Is everybody okay on that? So then I'm going to start putting it in the percent proportion. I put the change in the year, which is 20, over the exact amount. So how many exact actual students were there? 376. And I'm going to solve that to find the percent. So now it's what we've been doing. So 20 times 100 is 2,000 equals 376x. Divide by 376, and we're going to round to 1 decimal place unless it says something different. Okay, so on your calculator,
5.31.
okay, so on our calculator, we get 5.319, blah, blah, blah. Okay? I need to round it to 1 decimal place, so I want to round it to this one right here. This 1 will make it stay the same. So 5.3.
I'm done. What if you, never mind. Let's ask, if you could round 1 to 1 up, because of 9.
Well, we wouldn't need to round that up. Yeah. Nobody can borrow from the box. All right, we're gonna skip number 2, and we're gonna move on to the back, and then we're gonna eventually come back to number 2, so don't scribble it out.
Calculate.
All right, so we're flipping over to the back here, and it said, read each of the situations below and answer the questions using your understanding of absolute and percent error. So number 5 says, several students are competing in a science club competition to build a car that will travel exactly 10 meters. 10 meters. So that's the exact amount because it's telling me exactly 10 meters. The distance each student's car traveled is shown in the table below. So there's 3 different people. Emily's went 9.2, Jerome's went 10.6, and Maricella's went 9.8. So letter A, what is the absolute error? It's not asking me for the percent, it's asking me what is the error. Okay? So I'm gonna find the error, and I always take big minus small. So how far did Emily's go?
9.2.
9.2, so I'm gonna subtract. So the exact minus hers, so 10 minus 9.2, hers had an error of 0.8. So I just subtract the exact and what she got. All right, I'm gonna look at Jerome's. Jerome's went 10.6, but the exact was 10. So 10.6 minus 10, his had an error of 0.6. All right, you all do Maricela. Figure out what her error is. All right, so Maricela went 9.8, so 10 minus 9.8, her error is 0.2. Are there any questions about how to find the error with the subtracting? Okay, moving into part B. Part B said, what is the percent error? So that means I'm going to set up the percent proportion, and I'm going to do mine over here in this space, okay, underneath the car. So, I know that for Emily, and I'm going to do Emily in blue. I know that the exact amount they went was 10, and her error change was what? What's Emily's error change? 0.8. So, over here, I'm going to do 0.8, the error change, over the exact amount, which was 10, equals x over 100. Okay, so I'm going to put an E for Emily. So, error change over the exact equals x over 100. So 0.8 times 100 is 80, equals 10x. So divided by 10, and her error was 8%.
That's fine.
Go on. All right, I'm gonna try Jerome's. I'm gonna erase this because I don't have enough room. Okay, so Jerome, we start talking about these. Jerome had an error of 0.6. So I'm gonna do 0.6 over the exact amount, which is exact amount was 10 meters, equals x over 100. So 0.6 times 100 is 60. 10 times x is 10x. Divide by 10, and his error was 6%. All right, you all do Maricella's quietly, and I want you showing your work. Show your work. Show your work. All right, so Maricela, she had an error change of 0.2 over the actual, which was 10. So 0.2 times 100 is 20. 10 times x is 10x, divide by 10, and her change was 2%. You had a 2% error. Alright, it says on part C, based on this information, what does a small percent error indicate? If your error is very small, that means you're what, Luke?
They got closer to the goal.
Yes, they got closer to the actual amount. So we'll put on here closest to the actual amount. Or the actual goal, or the actual money, or whatever you want to call it. That's closest to the actual. Alright, I want you all to do part D. So all you're going to do is write true or false on those lines. Put T or F. All right, would you all say that Jerome has the smallest percent error? No, because who has the smallest percent? Maricela has the smallest percent error. All right, Emily's race car was the most accurate. No, hers was actually the farthest from being accurate, because hers was the farthest percent error. Emily and Marcella had a negative percent error because their cars traveled less than the desired distance. False, because percent error is not going to be negative.
Those are all.
All right, we're going to go back to the front now to do number 4. Stick around here. Okay, number 4 says, in a crowded sports arena, 250 seats are counted. If there is a 20% error, what is the range of acceptable number of seats? Okay, I'll tell you this. Here's something in real life. This is kind of really nasty. You ready for this?
No, thank you.
Okay, percent error is something that they use in the food making industry. Okay? There is a percent error of how many rat droppings or insect pieces are allowed to be in your food. Yeah, that it's like a percent error, it's like a safe amount.
It's protein though.
So, like when you open canned goods and stuff, or just like packaged food in general, there's a percent error of how many insect legs are in there. So that's a real thing. Percent error too is like car safety. Car safety has a percent error. Like if you're to hit a wall, it's gonna say the percent error for the front end of the car to bunch up is this to this. Like it should bunch up 20 inches to 30 inches. There would be like a percent error for that. Okay, so percent errors all around the world. We can Google that. We can see. But we will in a minute. So right here, in a crowded sports arena, 250 seats are the actual amount that are in there. They're saying that there's a 20% error. So what range of seats could they count? So I'm gonna set this up. I know my percent will always go above the 100. And since I know there are 250 actual seats, that's going to go on the bottom. So I'm going to be finding that 20%. Not yet, Raymond. All right, hold on. So I'm going to cross multiply. So x times 100 is 100x. 250 times 20 is 5,000. Divide by 100. And I get 50. Now that's not the answer. Okay? Listen, this is very important. The answer says that if there's exactly 250 seats, there is a range of 50 because there's a 20% 20% error. So that means
I know.
that 250 minus 50 is 200, and 250 plus 50
It's
is 300. So
I'm
if
sorry.
somebody says there are between 200 and 300 seats in the arena, they're within that percent error. They're within that 20% error.
Why can't I tell you?
So when somebody says there's a 20% error here, that means that the range that would be acceptable is between this and this. If they tell you that there is a 10 insect leg error, that means you could have 0 insect legs or up to 10 insect legs. Anything in that range would be acceptable. So in this one, anything in that range is acceptable because that's within the 20% error that we found. All right, on the back. Okay. I don't know how I always do this. Okay, on the back, I want you all to do this top part. Or I guess both of these.
Wait, Miss Wilson, I have a
So
question.
it says all of the guesses were between 342. There are actually, the actual amount is 408 gumballs. So what is the absolute error? And then what is the percent error?
Oh, I'm done.
So the first part just wants you to find the subtract. So subtract on the first part to find what the difference is. So when they're asking you for absolute error, that means what is the difference? And then the other part actually wants you to find the percent. So if you're gonna do 382, you're gonna do 408 minus 382. And that's gonna give you a 26 error. And you're gonna do the same thing with the 456. And then the bottom is where you're gonna do the percent proportion.
And then do I put 382 on top?
The change over the exact. Change over exact. How much did it change by? That's what you found on part A, over the exact amount that they told us in the problem. Alright, so the next one, 456 minus 408, and that gives us 48. So we should have 48 there. Alright, and then to find the percent error for 382. I know that 382 had a change of 26, so 26 over the actual 408 equals x over 100. The change over the exact equals the percent over 100. So 26 times 100 is 2600. 408 times x is 408x, divide by 408, and I get 6.3725, and if I'm gonna round to one decimal place, that would round to what? 6.4%. So I'll give you a second, if you need to fix the second one, go ahead and fix it. You didn't set it up right.
You got one of them.
Alright, so for 456, the percent error was 48. Or the error was 48 out of the actual 408 equals x over 100. So 48 times 100 is 4800. X times 408 is 408x. Divide by 408, and I got 11.7647. What would you round that to as one decimal? 11.8%. I'm gonna turn off the recording.